Welcome to section 10.5, which is the hyperbola. So we'll learn about the hyperbola. The hyperbola has a subtraction sign in between the x squared and y squared. And notice then that one of them is going to be positive and the other is negative. So there's two different forms, and we always let a squared be what the value under the positive term. So a squared does not have to be bigger than b squared. It's the ellipse where they're both the same that we have to pay attention to which one's bigger. But in the hyperbola, we do not have to pay attention to which is the bigger one. Everything happens in who the positive variable is, or the positive term. So in this first case, which I'll circle here, the positive term is the x term, and so things are happening in the x direction. What's happening? We have a center of 0, 0 again, just like for the same reasons in the last two sections. What's happening is we're moving out a distance a, right, in the x direction. Why the x direction? Because the x direction is the direction that has the positive value, right? The y is negative, the y squared is negative because of the minus sign out front. And then what c is, c or f, he calls it f. F is our focus, and our focus is very similar because what you got is two parabolas, so it's very similar to the focus point of a parabola. It's in the middle. Let me switch and I'll go to a different color like red and circle this one in red. Notice it's the y squared that's bigger. So you're still going from a center of 0, 0. And you're going up a distance a and down a distance a. And then the focus is at the b. I'm sorry, not the b. The focus is this point right here that's an f distance out from center. And so you'll find that we have he gives some terminology about transverse axes. The transverse axis is the axis along the major one. It always corresponds to who the positive term is. Okay, so yes, a squared is always with the positive term and b squared is always with the negative term. This x shouldn't be there. Just cross that out. So he's just giving the forms again. So if we find the vertex, he's going to focus on that first, and also show how we get the focus. The focus is the Pythagorean theorem. F squared is equal to a squared plus b squared. Now it's not actually it might be coming from the Pythagorean theorem, but it looks just like it, right? And that's why some books will refer to this F distance as c, so it looks exactly like it. But F is always farther away than the vertices, and so that's why this one's a plus. If you remember the ellipse, the focus were inside the vertices. It was inside the ellipse. These focus points got to be beyond the vertices, and so therefore it's a plus, and so that's how I remember that. And so again, he has a typo there that shouldn't have an x next to it. He's got two y squareds, so this should be an x squared right here, not a y squared, so just an x squared. So y squared over a squared, and this one's happening in the y direction. You're going a distance out of a. We'll see this all happen in an example. And so he's got another note here that's just kind of keeping everything together. He's staying with the 0, 0. And then he's going to bring up the asymptotes. The asymptotes are pretty nice. We do have asymptotes that these follow. Many books will require you to find them. We'll see what he does. If he's talking about it, he's probably requiring you to find it. And so he's getting it by a box, which will often work. So he's plotting the point AB, A negative B, negative A, negative B, negative AB, connecting the dots and drawing those diagonals to it. That would work. There's an actual equation, though, that would be better. But if he's just asking you to draw them, we'll draw the box together. So we'll see. There are two slant asymptotes, right? He's just summarizing everything. Let's see this in action. Let's go to an example. Make sure that they're done correctly. So here's example 1. So what we should get out of example 1 is that we have a hyperbola, first of all. So hopefully you look at this and realize, oh, this is totally a hyperbola. First thing that tells you it's a hyperbola, well, the main thing is this minus sign right here. The circle and the ellipse both have positive signs in between there. The parabola doesn't have two things being squared. It just has one thing being squared. And so we get that right there tells us it's a hyperbola. Because it's a hyperbola, we know everything is happening to the term that's not squared. So we know that this is opening up in the x direction. So right away, we can start making some observations that our center point is at 0, 0, which isn't part of the graph. Let me go to a part of the graph. Now, where's our vertice point? 1, 2, 3 out. 1, 2, 3 back. And we have this hyperbola. It's going to be opening just like this, right, with the focus point in the middle. Now, what are some other things that we can do? Well, we can identify A and B. So remember what he said. You can get the asymptotes. So let me do the asymptotes in green. You can get the asymptotes by going to AB, right? So 3, 4, and putting a dot. A negative B, putting a dot. Negative AB, and negative A negative B. So you got this box shape right here that's coming right through these, right? It's not part of the graph, but it helps us because what we follow is these lines for large values. So it's basically, it will tell us the width of this guy. So if I go back to my blue and draw this a little bit better, I'm going to be coming out to these lines right here. So it definitely helps me to get a good feel of the shape. That's the advantage of knowing the asymptotes. But it was never any harder than saying, okay, this is the point AB, negative A. Oh, sorry. This is A, negative B, negative AB, and negative A, negative B. Right? And you get that nice box out of there. So that's what he's going to be doing. So he finds that his focus point is at 4. Or sorry, 5. That's the one thing I have not labeled that's a part of my graph. Let's watch that happen. F squared is equal to A squared plus B squared. That's a 9 plus 16, or 25, so F is 5. So my focus point, let me come back out here and get a darker line. My focus points are right there. So that's the way my graph looks. The hyperbola is what's in the blue right there. And so he's having you go through all of those and coming up with, exactly what we had. Again, his scaling is a little bit off. Take a look at the long scaling along the x-axis and the short scaling along the y-axis. That's why it doesn't look exactly like mine. But same principle, same points being labeled. So you're going to do this. You're going to be like, hey, I can do this. This is not bad. So he's going to start you out. I'm really happy about this. He's giving you right away something where the center is not at 0, 0. And so here we see the same thing. We see that it's a hyperbola because of the subtraction, right? When you're on your test, you're not going to know whether you have a hyperbola or an ellipse unless you look at it. And so we have a hyperbola because if it was a plus sign in here, we'd have an ellipse. Let me go ahead and erase that so that doesn't confuse us in the future. So the center is at 1, 2. And everything is happening in the x direction. A squared is equal to 16, so A is 4. And B squared is 9, so B is 3, right? That I just duplicating that information. It's going to be the same focus of 5. So the only difference between example 1 and example 2 is where we start. So we're still going to go 4 units out in the x direction to get to the to get to my center point. To get to my vertex from the center. So we're still going to go out 4 units to get there. So our center is at 1, 2. We're going to go out 4 units and be at 5, 2, and back 4 units and be at negative 3, 2. We're going to go out 5 in that direction in order to get the focus point at 6, 2, and another focus point at negative 4, 2. And so we get those very easily. Now, let's talk about this box. The box isn't, if you have a center that's not 0, 0, the box you got to be careful about. It is A units out and back from the center and B units up from there. So remember, we had I'll put them in blue. We had these points already. So all you're really doing is respecting B now. B was 3, so you're going 3 units up from that vertice position and 3 units down to get your 2 dots. That's a more intuitive way to see it. And then from the vertex point, you're going to go up 3 and down 3 and get those and then connect those dots. So it's pretty easy to come up with those if we take some practicality. Now he's going to switch the y squared. Everything else is the same. A 0, so this is going to be like example 1, except now it's happening in the y direction. So we can watch that happen. Go 3 up, 3 down. Here's our vertex at 3 up, 3 down. Whoops. Somehow I messed up there. Okay. All right. It's another example. Sorry, here we are. Here's an example of 3 up, 3 down, and we got our guys right here. This should be a negative 3 down here. And then again, what's the B? The B was 4, right? So if we go up here, it doesn't matter that the 9 is less than the 16. The B is 4. We're going to go out 4 from the vertex point and go 4 to the right, 4 to the left, 4 to the right, and that's what's going to create our box. And our focus is 5 points beyond there. And then very similar to example 2, good, different numbers here, but everything's happening to the y. A squared is 64, so A is 8. B squared is 36, so B is 6. And F is going to be 100. That all looks good. So F squared is going to be 100, so F is going to be 10. So remember, our center is at negative 1, 3. So, oh, apologize, I read that backwards. 3, negative 1. Be very careful. I fell into a common mistake. 3, negative 1 is our center. From the 3, if you remember what A was 8. We're going to go 8 up to get to 3, 7, and 3 down, 8 down to get to 3, negative 9. Remember, our focus was 10, so we're going to go 10 units up. Sorry, my hand hit something there. Okay, so let's make sure. Our focus was 10. Negative 1 plus 10 is not 11, it's 9. So that should be a 9 up there. And then a negative 11 is correct down there. So mistake only in that top vertice. And then once you have the vertices, just go the B distance out. So what was B? Let me remind myself what B was. B was 6. So 6 units from 3. 3 plus 6 is 9. 3 minus 6 is negative 3. And then you're going to get those same two numbers down here and connect the dots in order to draw it. So what else will you be asked to do? You'll be asked to come up with an equation utilizing a focus and a vertex that's given. Right? Center's at 0, 0. There's a focus. There's a vertex. And we're just going to walk right through this process. So what do we know? We know things are happening in the x direction. So right away we know it's x squared minus y squared is equal to 1. We know that underneath the x squared is a 9. We know that our focus distance is 5. So we know that 5 squared needs to be equal to 9 squared plus b squared. Or that 25 needs to be equal to 81 plus not 81, not 9 squared. Apologize, I made a common mistake. So A is 9, A is 3, A squared is 9. So I knew that right away because I was going to end up having a problem. So this is a 9 right here. A squared is 9. And this is b squared, and so what do we get? We get a 16 out for y, and we're finished. You can watch him walk through those steps right here and come up with the same equation. So I'm hoping to just be able to give you kind of a way I would do it, and then we can look at his. So you have two vertices. So once again, we know everything's happening in the x direction. They tell us it's a hyperbola, so we know it's x squared. Oh, we don't know the center. The center is in between those, right in between -6 and 6 is 0. So our center is at 0, 0 again. And so we have x squared, not plus, sorry about that, x squared minus y squared is equal to 1. And what's underneath the x squared is whatever a was. A would be the distance from the center out to the 6's. So it's 6. So a is 6. And so a squared is 36. And we don't know what b squared is. Well, that's why we're here. Do we know what f is? Yeah, f is 10. So now we know 100 is equal to 36 minus b squared. Or sorry, plus b squared. So b squared is equal to 64. And so we come in and say, oh, I can finish this. It is x squared over 36 minus y squared over 64 is equal to 1. And we can watch that all work out here. Right? And so there's his justification as well. But I just wanted to give you a verbal description. All right. Center is at 1, 2. Focus is at 11, 2. So you can see right away that things have changed in the x direction. So here's what we know. That we have x first, and it's a -1. We have y second, and it's a -2. And this is equal to 1. We know that the distance between 1 and 11, which is 10, is the focus distance. So the focus distance is 10. Between 1 and 4 is the a distance, and so that's 3. So this is a 9 underneath here. So what do we know? We know don't know why he's saying 7, 2. The vertex is at 4, 2. Does he consistently use the 7? Let's see. No. So yeah, he's using 7, 2. Let's make that adjustment since he's using 7, 2 in a few places later on. So that makes that change. So the distance between 1 and 7 is now 6. And so this is 36 under here. Okay, so what do we know? We know 100 needs to be equal to 36 minus b, or plus b squared. So b squared is going to be 64, and we're finished. We get a nice 64 under there, and we should match, yeah. So it was wise to change the one typo there. It wasn't a problem. Here the center's at 0, 0, one focus at 3, 3, and a vertex at 0, 7. So we're back to the easy stuff because it's, everything's happening to the y, right? So I'm not going to start out with x. That's why this seems so similar, but different. So it's y squared minus x squared, because the center's at 0, 0, equals 1. The distance between... so he's got these labeled backwards again. A focus at 3, 3 is not possible to have a focus at 3, 3. And so we can take a look at his picture and change. The focus point is 0. Oh my goodness. The focus point is at 0, 7. The vertex is at 0, 6, and I think everything will work out okay. We could not work with those two because the focus was inside the vertice. Focus needs to be outside. So if we do that, then we know that there's a distance. A is equal to 6, so a squared is equal to 36. And remember, a goes underneath the positive variable. And so what do we know? We know that our focus length is 7. So we know 49 better be equal to 36 plus b squared. And if we take that off, we get a 13 is equal to b squared, and we should be done. So let's see if he gets the same thing. He's getting his 11 again. He had that same 11 before, but I believe 49 minus 36 is 13, and so we're good there. Okay, just change those all to be 13s. Okay, And then of course he's going to have a y example where the focus is, I'm sorry, the vertex is different, and then one more example after this. So we have a vertex at 2, 4, and the foci are 2, -5 and 2, 5. So we're given a focus. We're given 2 foci points and a vertex. So we're not given the center. So we're going to use the 2 foci points to come up with the center. The center is at 2, 0. That's where our center is. And everything is happening to the y. And so if we look at, got to be really careful here. Our center is at 2, 0. That's what he's noted as well. So now everything's happening to the y. So we have y minus 2 squared minus x squared. We know this is always equal to 1. B would be the distance between this, I'm sorry, A would be the distance between the center and the vertex. And so that looks like a distance of 4. So A squared is 16. And the distance between the center and the focus is 5. And so F squared would be 25. So we need 25 to be equal to 16 plus a number, and that to be 16 plus b squared. So if we subtract off 16, we get 9 is equal to b squared, and we're finished. Right? We should end up with a 9 right underneath there. Perfect, with the y squared overall. And so last one, example 6. I don't know what that last part is there. I was thinking it was for this one. But example 6, a focus point is there, and then 2 vertice points, 4, 1 and 4, 9. So we got 4, 5 as our center. Right in between 9 and 1 is 5. And so everything is happening in the y direction. So we know it's y minus 5 squared minus x minus 4 squared always equals 1. And our job is to find out what's underneath. We definitely know that the distance between 5 and 7 is 2. So a is 2, and a squared is 4. So we know there's a 4 underneath here. And the distance between, let me back up there for a minute. We needed to find the difference between the center point 4, 5 and the vertice points are 4, 1. Interesting. This is all weird. He has this all weird because he has things labeled differently here. So 4, 5 is definitely the center, right in between these guys. But take a look. He's got 2 vertices at 4, 1 and 4, 9. Right? 4, 1 is a vertice. This should be a vertice as well, the way he has it labeled. And it's good because that's a distance of 4 away. This 4, 7 cannot work. So this example is all messed up because he can't even adjust it like the way he's doing here, because there's a distance between 2 here but a distance of 4 here, and that's going to be a problem. Those vertices need to be equal distance away. So his labeling's all wrong for this problem. So I would skip example 6, not worry about it at all, in the sense that it's not going to help you. We could adjust some things, but as he's making these adjustments, they're not working out quite right. So this example 6 is not worth our time, but you'll get other examples in there. I think what you have so far is good, but again, let me know if there's supplementary work I could do for you.